First of all, let me introduce the container structure. Behind me, this is the maintenance door. During the operation and running of this whole system, the door could be closed for sure. Only when the maintenance work required, we can open this gate. And it's easy to access to the toilet towers here. This side installed with the cylinder filling ramps. The cylinder filling ramps, the high pressure oxygen coming from here, and we have the right side and left side. This is the pressure gauge of the filling oxygen. So we can read the pressure of the oxygen coming to this side, and this is the stop valve if all the cylinders are fully refilled. So we can close the valves here of each port and close this stop valve, and oxygen will not come into this side. And the left side is same like this. And here has a total valve. If we stop the refilling ramp, we can valve here also. And this is the safety valve. The safety valve will discharge the oxygen once the pressure higher than a certain value. So this is the cylinder filling ramp. And come to this way, let me show you the ventilation of the whole system. Here has 3 windows. This one and this one inside built-in with a fan. The fan would help to take out the air inside the container. And the fan installed with the temperature sensors, it would automatically start to work when the environment temperature is higher than 25 or 30 centigrade. And this is the exhaust duct of the air compressor. During the process of the air compressor, lots of the heat energy would be produced. So we have to pipe out the exhausted airs. So through this exhaust air duct, heat air could be sent out of the container. This one is the entrance door of the container. We can go inside the container, and the backside still have the inlet port. Let me show you the backside of the container. The container need a very good ventilation situations, except the air outlet line and windows I just introduced there, and this is the air inlet. The air inlet from here, the container have a good ventilation conditions. Air come in from here and get out through the windows in that side. Here is the power source cable inlet port. So the city power comes from here to send power to the machine through this port. The machines cannot working under a very high environmental temperature, for example, more than 50 or 45 centigrade. And so we installed one air conditioner inside. This is part of the AC here. So this is the whole structure of the container. Next video, let me introduce the inside details of the container. This is Nico from Zoomedic. This video is to introduce the detailed components of the oxygen generator system. First of all, this is one set of air compressor. This air compressor is VSD screw type air compressor, which is very energy saving type. And this has air inlet ports, and these filters can be easily taken out, refresh, put back. This is touch panel of the air compressor. We can do the simple operations and read the working data of the system through this panel. And it's also remote controlled by the generator system. Top side is exhaust air duct connect with the outside duct, which I introduced in the last video. And the surrounding air take in into this air compressor. After processing, we get 8-bar outlet air compressor, which high temperature is piping out through here. And this is air receiver. This air receiver would storage the 8-bar compressed air in here. And this is the pressure gauge. We can read the inside air pressures through here. At the top of the air compressor is the safety valve. The safety valve would start work when inside pressure exceed a setting value. At the bottom of this tank is the water drainage. Here installed with a valve. When the system is on, we should keep this valve on. So the drainage water could pipe out of this water tank. And after the water drainage connected with air filter, this air filter main function is to separate the water inside the compressed air, and it connected with automatic drainage valve. This automatic drainage valve would automatically to pipe out the water through this air filter. After that, this stainless pipe sends the compressed air to this refrigeration dryer. Refrigeration dryer, its main function is to cool down the temperature of the compressed air. Because compressed air is with high temperature, burn with lots of the water. So we use refrigeration dryer to cool down the temperature, and the gas would change to liquid water. So liquid water would be separated from the compressed air. And let's check here. We have to make sure and note that here is the switch. During the operation of the system, please make sure this button is always keep at this status, not move it, because this refrigeration dryer is remote controlled by the oxygen generator control unit. So compressed air come inside, cool down, separate water, and compressed air coming out through this pipe, stainless pipe. After the process here, lots of the water separated through here. So stainless pipe sends the compressed air to the air filters. We have 3 air filters here. These 3 air filters, the first one is to again separate water from the compressed air, and it's connected with the drainage valves. And here we have to make sure this red valve keep on, so the water could be piped out always. The second air filter is the AO air filter. The AO air filter is to remove the dust particles, oil, and water also with the compressed air. Same connected with the automatic drainage valve. Always keep the valve on. And the next one is AA air filter. This AA filter is a higher precision filtration air filter. It would remove the smaller size of the dust particles, oil, and water inside the compressed air. And it also connected with the automatic drainage valve, and this valve also always keep it on. So after this three-stage air filter process, the compressed air remove the water, remove the dust particles, remove oil, it become clean. So it's clean compressed air. And again, we have to process the compressed air. The compressed air sent to the air dryers. These 4 tanks are the air dryers. These air dryers filled with 13X molecular sieve and activated alumina. This alumina and the molecular sieve would absorb the balanced water inside the compressed air. So after this process, it makes sure that the compressed air become very dry. So after this process, we have the dry and clean compressed air. The clean compressed air through this pipe sent to the dry air receiver. So this tank is to storage the ready feed air. This feed air is dry and clean. It's ready for the oxygen separation process. And we have one more air filter to make sure air is extremely clean, and the ready feed air would through that pipe sent to here. This is the molecular sieve towers. Inside these towers, it filled with zeolite molecular sieve. Zeolite molecular sieve would separate nitrogen in the compressed air, so we could get high purity oxygen after the PSA tower separation process. Separated oxygen could reach a purity to 96%. So the produced oxygen could storage in this tank. So this is the oxygen receiver. This oxygen receiver would storage the high purity oxygen. Let's see from here, the produced oxygen, we still have lots of the processes. These two are the oxygen filters. ACS filter filled with activated carbon. The activated carbon would absorb the oil mist and remove the odor from the oxygen. This one is AAR oxygen filter. This AAR oxygen filter is a very high precision process. Oxygen filter, it would remove very small dust particles and oil, other small things in the oxygen. After that, this is pressure regulator. We can regulate the outlet oxygen pressure through here, through this valve. Take it up and turn to adjust the pressure. After adjust, push it back. This is the process. Here is the silencer. Let's check here. This is the oxygen flow meter. This oxygen flow meter also support with remote transmission function. So we can read the real time and total flow rate of the whole system through here or through the control unit. This is a pressure sensor. And through this pipe, the produced oxygen would send to the oxygen tank. This is an oxygen tank. It would storage the ready oxygen in this tank, and we can read the pressure through this pressure gauge, so we can know how many oxygen storage in this tank. Through this pressure tank, we can see the pipes. Through this pipe, that produce the oxygen. Here, sent to the oxygen booster. This oxygen booster is to introduce the oxygen pressure from 4 bar to 8 bar. So if we need this 8 bar pressure oxygen, we have to let the switch on process here. Pointing to this side, the machine would be on. The piston type will start into compression and make the oxygen pressure arrive 8 bar. And if we do not need 8 bar oxygen, and we can switch it off, keep it off. Oxygen come inside in this way after process, came out in this way through this pipe. 8 bar oxygen coming this way, will storage in this tank. So this tank is filled with 8 bar oxygen. It coming out through this pipe to the oxygen alternate port. The alternate port would connect to the oxygen pipeline system in the hospital, so the oxygen could deliver to each department in the hospital. One more route, let me share you. 4 bar oxygen pipe. There's another pipe sent to here. This is the oxygen refilling booster. Oxygen refilling booster is here. It's a 3-stage oxygen refilling booster. This is the motor part and 3-stage. First, second, and 3rd stage. Backside is the fan. The fan supplies the air cooling. The 3rd stage here is connecting with the water cooling, and the water tank is here. We can refill a coolant or water through here. So the machine could running at a very good cooling situation. And let me introduce about this part. Oxygen coming inside. This is the inlet valve. So during the operation of the system, this valve always keep it on. Go inside. After 1, 2, 3, 3-stage operation, the 4 bar oxygen could arrive 150 bar high pressure oxygen, and it will come out through this pipe. And make sure that because we are sending the high pressure oxygen through here, and this red valve, please make sure always off. Only when the oxygen booster and the refilling ramp is on, we open this valve. If not on or not working, make this valve off. And this high pressure hose connecting to here is connected with the cylinder refilling ramp, which I introduced in last video. Control unit is here. The control unit would display the running pressure of the system. Switches, air brake inside. Only this air brake on. Other parts remain it, please don't touch. Only make this air breaker on during the process. That's the system. And the air conditioner at top. This part is an electricity distribution box of the whole system. This is the power of the whole oxygen generator system. When the machine is on, this point to here, the power would be on. If we switch and point to O, it means the system is not connected with power. And the other air breaker make it all on, like this. So this is a power distribution box. Next, let me introduce you the control system of the oxygen generator. Here's the control unit of the oxygen generator system. This is a touch panel able to net the operate and read the running data through it. And the emergency stop button, please make sure only use it when there is a very emergency situation. This button, keep it as manual. These are the details of the machines of the oxygen generator system.